So this is my talk, and there's a link. It says recursion because the slides link to themselves. So the slides are online. If lines of text are underlined, they're links. So if you check out the slides, you can click links and stuff like that. That's my Twitter and that's my GitHub. So kind of a disclaimer. I'm usually doing talks together with Einar. And usually he does most of the talking, and we don't have proper slides, so I'm trying to do like a proper talk. It will probably be like weird and full of mistakes, but we're hoping for no one. So hi, I hope you like objects. This isn't a very good joke, but I'm going to open a Smalltalk image, and it has objects in it. And you know, everything's an object, so that's good. And we'll move on. So the first part is like some background on why this is a talk, and some intro and sort of what it's going to be about. I'm going to show a little bit pure script code, and it will touch on some general functional programming things, I hope. And it will be some kind of web developer wiring stuff together from the perspective of someone who doesn't know how to do web development. And this is sort of mildly related, but it's a quote I like a lot. So I put it in the slides because it's an opportunity to link to that interview. So this thing with having like one good idea, I think I decided that as far as conferences go, my good idea has been to put evaluators inside text editors. So we have been doing that for some years, and for some reason we get invited to conferences. And the reason I did that was that because when I started looking into lambda calculus, I looked at the Wikipedia page for lambda calculus, and I started writing things like these notes here. So I wanted something like this, but where I made less mistakes. And Notebook is kind of like a text editor, so I tried to put kind of those mechanisms into a text editor. And this is kind of the reason why I booted up a Smalltalk image, because by day I do a fair amount of Smalltalk programming, and so that the idea of like putting evaluation into a text editor is like clearly not my idea, because in Smalltalk, whenever you're like working on a method, so this is the method definition, and you're writing a useful method, and if you're suddenly like wondering like what is 3 plus 4, you can press some shortcut and have it evaluated, and it prints the result in the editor. So that's kind of how Smalltalk does the kind of REPL, the read eval print thing. So pretty much whenever you get to write code, you can also evaluate code. So that was kind of natural for me to decide that, yeah, I want the output of the things I'm writing sort of pasted into the editor that I'm working in. This is kind of neat, but it's really surprising to people who are new to Smalltalk, because sometimes you expect that you are the one who is writing code in your editor, but then the Smalltalk system kicks in and does stuff. If you're lucky, it will like paste error messages into your code because you try to save something that won't compile and stuff like that. So it's full of surprises. And that led to talks that tend to look like this. They're full of lambdas. So because I put like a lambda calculus evaluator in a text editor, and I showed it to some friends and colleagues, we made a talk out of it, and some years later we got to do a talk here. I copied this from the file we ended up with last year here. I think it's part of the computation that does the multiplication of 10 times 10 or something. So yeah, we ended up being here last year, and after the talk, someone actually asked us like, well, if we want to do this or use this in a course or something, where can I download this tooling, or can I use it easily? And that's not the question we usually get, so we didn't have like a good answer for it. I had answers like, there's a Sublime plugin that was the first version that I made that has a kind of awkward install procedures because I never looked into how to do like proper Sublime plugins. And also I know by now that parts of it are incorrect. And then there's a kind of Emacs setup using standard ML, which is what we used last time we was here. And these days I use Emacs with a Racket program running in the background. And the two last ones are like nice answers to give if someone likes Emacs, particularly if they happen to have like standard ML or Racket installed. If they don't, it's not like the easiest thing to link someone to and have them set up. So a less awkward answer would be to have like a link, and you said go to this link, and then you can play with stuff in your browser. So me and Einar talked about this, and it sounded like a nice thing to have. And I basically don't know anything about web development, but I started looking into it. So this kind of gives away the conclusion, I guess. But yeah, we're online. So we ended up with this thing that runs in the browser, and you can do most of the things that we did in last year's talk. Define a bunch of stuff, do a bunch of computation, get a ton of lambdas. So that's kind of where it ends up. And yeah, there were basically two things I wanted to do. I wanted to have this editor that people could play around with, and I also wanted to be able to write like blog posts with lambdas in them. So I wanted to be able to embed this editor in multiple places in a page and have text surrounding it. And instead of just having like examples and insisting that this is going to work, if someone were to read it, they could, run the stuff in the browser inside the blog post. So those were kind of my goals. And the challenge then was that I didn't know how to do web stuff. But like I mentioned, I've done some standard ML. I played with Haskell. I've used Elm a little. I have an earlier version of the editor running in Elm, except it's not actually an editor, but at least it's in a web page. And I knew that PureScript is a thing. And PureScript is very similar to Haskell, and Haskell is kind of similar to standard ML. So I figured with PureScript I should be able to write some code. With JavaScript, I might not. And I know like very basic HTML, and I picked up the CSS I needed in order to make pages that look this fancy. And at roughly the same time, someone mentioned Monaco. Monaco is a code editor that runs in the browser. It's used by Visual Studio Code. And there are multiple editors running in browser, but someone said the word Monaco, and I had heard about Visual Studio Code, so I tried to use that. I'm sure any editor would be a good choice for me. I don't have like very high demands. I don't want syntax highlighting. If an expression doesn't parse, it's usually just to add parentheses until it does. So it's a simple language. I don't have that difficult needs. So yeah, the second part of the presentation will be the PureScript bits. And yeah, PureScript is a language that has like a bunch of sensible things like in standard ML, and it has a bunch of weird Haskell stuff. I mostly avoid the weird Haskell stuff, but I kind of encounter it in the libraries I use. So I haven't made my own type classes and stuff like that, but sometimes you have to implement a type class or make an instance of a type class in order to do stuff like print a value in your REPL. So the PureScript code is going to be sort of the same kind of code I would write in standard ML or F# for the most part. And there's a getting started page for PureScript. It looks like this. And basically what I did was I found this page. I did all the things it said I should do. So I installed NPM. I installed PureScript using NPM. I installed Pulp and Bower. So Pulp is sort of build tools that helps you set up a Bower project for PureScript. I have no idea what to do with NPM and Bower and stuff like that. But I've like dealt with some Maven stuff, so I'm used to the idea of installing a package manager with a package manager. And then I kind of grabbed the first thing I found for using as an editor, which was I saw some people were using Atom. I'm not sure if I had used Atom before, but it seemed to have like easy install procedures. So I downloaded Atom. And with a couple of plugins, you can make it draw like dotted lines under stuff that is wrong. And it will do like syntax coloring and stuff like that. So I downloaded Atom. I found the settings. And I searched for PureScript. And I clicked the two first install things. I did not click the following things because they were for TypeScript or just script. So they were other stuff. I'm not entirely sure you need both of them, but I think so. And then you get like these IntelliSense things. As you can see, you get like the documentation that's taken from the source code, from comments there for the thing you're selecting. Kind of nice IDE things you might want. And you get stuff like the exclamation point on the side there, and this underlined thing. There's a red dotted line under there. If you look close, you can see that I've written ter where I should have written term. And then you can get the error message that the PureScript compiler would give you. And I discovered that if I mouse over the exclamation mark and then move over to the bit of underlined code, I get like 2 error messages on top of each other, which I thought was nice. And yeah, so part 1 is also about lambda calculus, kind of unfortunately, because that's the core domain of my application. So it's a formal system for computation. It's Turing complete. It has functions, and that's about it. So what I want to do is I want to be able to read stuff like this, parse it into a nice data structure, and do like computation and evaluation and print the results, turn back into strings or something. And it consists of 3 things. There's lambda abstractions, those are functions. It has function application, which are like function calls, and you have variable references. And this means you can this is the syntax tree, I guess. So an expression like this is an application where the left-hand side is a function and the right-hand side is this reference to the variable bar. And you see inside there is an application and a reference and so on. So I need like a data structure to represent this stuff. This is how people like to write like the syntax if they're doing like textbooks and stuff. So you have an expression u. It can be a variable. It can be an abstraction, that's lambda x.u, or it can be an application. And if I translate that to like PureScript code, you get a data structure. And it's supposed to be like roughly the same thing. You have variables. So you have var string. It has a string which is a variable name. You have lambdas, and you have applications. And it's a recursive type, so you see that term shows up in the right-hand side, which refers to the data type that is being defined. So we want something to this to parse to something like this. So parsing. You search for PureScript and parsing, and you get a library called PureScript parsing. It's kind of okay for parsing. And, well, it's, what does it say? It's based on Haskell's parsec, so it's a partially combinated library. And you get like some kind of nice code. There's a theme going on where you have to pass in a parser that's supposed to be the parser for the whole expression into the kind of parsing of a lambda that needs to parse an expression that can contain a lambda. So there's some recursive stuff that complicates things. So there's a fair amount of stuff ends up being like a function from a parser to a parser, where maybe you'd like it better if it was just a parser. It's a parser monad, I think. So you get to use like the Haskell do notation if you do several things. And some of it is readable nice, so you get stuff like, well, it should start with a string that is either the lambda character, or you can use a backspace if you don't like to use lambdas. And then identifier comes next, and this is the name of a parser that parses like variable names. And we keep that in a variable named p, and we want a dot. We're not interested in this return value or this return value. And we parse an expression, and then we kind of return with this pure thing, which is one of those monadic operations, a lambda with the parameter and the body we parsed. So those are kind of, at least the code reads nicely, I think, and you can sort of, by knowing what the syntax is like, you can find the same tokens there. And you have stuff like this, which like runs off the screen. So in order to parse an identifier, I have a set of reserved characters that should not appear in identifiers. And I use some stuff like many1, which should only succeed if there is more than one character. That should satisfy that the character is not a member of the set reserved. And then there's like stuff going on which we won't get into. And then there are some functions that I kind of like the implementation of, because it's like between these two things, there should be an x. So between two parentheses, there can be an expression, and you'll parse that as you would. So it will result in the same as just parsing the expression. And you get like this type. And I have no idea what is going on. There are parser t's, which I think might mean like the monad transformers for parsers. So like Haskell people like to tell you that you get a lot of information from the types. And it's kind of, you better get a lot of information from the types, because there's a lot more type than implementation here. It would be like really sad if you didn't. So that's like a couple of parsing functions. Yeah, as I said, all the links are to like the GitHub bits where those lines show up. And unparsing, that's all of my unparsing code. We won't get into the details, but it turns terms into strings. So if it's a variable, then the name of the variable is the strings. It does like pattern matching on the type we defined earlier, and it calls unparse recursively on like subterms. And well, this bit is string concatenation. So that's one thing we want to do. We want to turn these things back and forth between strings and these terms. And then there's the computation bit. So a side note here is that we don't look up variables in the scope. Like if you implemented, say, a Lisp within a Lisp, you might have done this thing where a function is defined to be, you know, f of x is x plus x. And the implementation technique is often like, well, if you find f applied to the number 2, you kind of keep in mind that x now means 2, and you evaluate this expression. And whenever you come to an x, you look up in your environment what the value of x is. But the way we like to think about this is that f of 2 is 2 plus 2. So when we get to something like this, we take this thing here and we replace all the x's with 2's. Again, this is kind of the thing I've written like this terrible slide where you probably can't make out what's going on. But this is what you're doing by hand if you're doing like lambda calculus by hand. And I want to mention this book because I really like that. When I read this book in the first chapter, they introduced like the substitution model for procedure application, which does this thing, and is kind of how they suggest that you should think about application of procedures or functions. And then in chapter 3, they introduced like the set bang operators, so the assignment thing, and the substitution model falls apart, and they have to like think about these environments being carried around. And well, we're going to look through for something we call reducible expressions, or regex, which is an application, and there's a lambda abstraction as the function bit, and some expression as the argument. So we look at something like this, and we should be able to like find this application and pick out these parts. And when we have done that, we do the thing we call beta reduction, which is we keep the body of the lambda, but we replace all the references to its parameter by the argument. So we really want to like find this argument and the body of the lambda in addition to the argument being passed in. So we want to like look at something like this and find these bits and pieces of it. So we want to find that the argument is bar, the parameter is a, the body is this stuff. And then we have like this stuff, and we want to do like swoosh and get this stuff back. So given this thing, we want to find this and replace all the a's with bar. So this is like the bit that does computation. So finding a reducible expression, that's, you know, finding these things. We're skipping this bit, but I'm just showing you the bit that checks if an expression is reducible. I'm not showing you the code that kind of searches through the syntax tree. So we have some stuff for looking through a tree and looking for something. And we have this regex function, which checks if a function is a reducible expression. And this is kind of the kind of functional code with pattern matching that I like a lot. So we make a data type which holds on to like where we want to stuff like these three things: the argument, the parameter, and the function body. So we have a regex data type, which has a term that is the argument and a string that is the parameter and a term that is the function body we are going to do substitution in. And then if it is an application and it has a lambda, then we pick out these bits, which is the argument, the function body, and the parameter, the function body, and the argument that is passed to the function, and we return this regex. And if it's something else, we return nothing. So you're using that maybe type, same as you would in Haskell. And like, given this thing we started with, this match we are doing here should match like the app should match this, and the lam should match this, and so on. And we are able to like pick out the bits we are interested in. So for the code we are writing here, if we get to that part, then the variable p is bound to this string, and the b is bound to the function body, and so on. And then there's the substitution bit. So we want to do like this thing. And the substitution function, well, it does this thing. So it takes some body that it's going to do substitution on, and it takes the parameter that is going to be replaced, and takes the argument that is going to replace the parameter. And again, we get this kind of nice pattern matching function. I say if it's an application, we call this helper function on the function bit and the argument bit, and we sort of reassemble it so we get an application back. And if it's a lambda, we do the same thing, and then there's some shenanigans in case the parameter we are replacing are being reused within. And at the end, the important bit is that if we get to a variable and it is equal to the parameter we are replacing, we just return the argument, or else we return the variable we started with. And then, the code contains like additional stuff for, we want to have like top-level definitions, and we need to, this isn't enough to do the computation. We need a bit of additional stuff to deal with what if variables are like shadowing each other and you're substituting something into the wrong place. But this is kind of the essence. And it's a function that I think kind of nicely follows the data type definition. It's recursive in the way the data type is recursive. It matches all the cases, all of that stuff. Me and Einar have done a talk that is about this kind of code, where we implement an evaluator. So I stole a couple of slides from that. So the idea is that we want to end up with some program like this, where we get input strings, we parse them, we do these beta reductions, and the output should be these intermediate steps of computation. And I wanted to mention this thing called Boolean blindness, which is a blog post by Robert Harper. And it's often a good idea to return the stuff you need for the next bit of computation instead of like returning a Boolean, which is seldom the thing you need in order to do the next thing. So a thing you might do if you're writing this function is to say that the regex function that checks if an expression is reducible should return a Boolean. But what I'm doing here is I return a value of this type that contains all the stuff that the substitution function happens to need. So it's kind of nice when these things fit together. So you see term might give me a regex back. Substitution requires a regex to move on. So data types are kind of important, I guess, is my point. And kind of unsurprisingly, if you have like better data types to begin with, the functions you end up with are also better. If you introduce lambdas to JavaScript, to Java, and you don't introduce like some types and stuff, you get like more functions, but you might not get like more interesting types for them. So you get a bunch of mapping stuff, but it might not be that much easier to write in a good functional style. Also, I totally did like the thing I think is really dumb the first time around. So in the Python code for the Sublime plugin, I did this thing where I returned a Boolean, and I ported it to Elm, and I did the same thing. And I ended up with this pattern match that only matches this thing, because I know that since this thing returned true, then this thing will always match. And I get like non-exhaustive matches warnings, and in later versions of Elm it won't compile, so I switched to a new language. So this is the last part. So since PureScript was kind of mostly straightforward functional code if you're like used to that kind of functional language, the bit where I didn't know what I was doing was when I needed to like put it inside a web page. So there's a thing about like functional architecture, or sometimes called like onion architecture and stuff like that, that you want to have like pure functions, nice values in your kind of core domain bit. And outside of that, you can have like a layer with states and effects and stuff like that. In Haskell, this is often done with using like the IO thing. So the main function is of type IO something, and you can do all your effects and stuff, and you call into these pure functions inside. In PureScript, they have the F monad, which I think is roughly like I/O, but more specific. So you have stuff like a console type, which only does console effects. And in this book that I like, they mention a thing called modernized Algol, which is kind of the same idea, but they use an outer language which has commands and stuff, and an inner language which is purely functional. So I thought, well, I could, if I don't want to look into F, I can use this book as an excuse to say that, well, my outer language is JavaScript, and it will do effects and stuff, and I'll have like a nice functional core written in PureScript. So I made like a couple of PureScript libraries, and then I did sort of wiring in JavaScript where I connected it to the web page and to the Monaco editor. And, well, this is kind of the idealized dependency diagram for the application. In reality, the HTML file refers to the JavaScript being included because that's how browsers do things. But that's my idea, that I have this stuff on the inside, and it should know about Monaco, it should know about what my web page is like, and it should know about my nice functional core. The core domain bit, I think I've done like reasonably properly. I called it PureScript Labs. It's the implementation of the Lambda Calculus Evaluator that we looked at earlier. And I've done it so properly that I have uploaded it to Bower and to Pursuit, which is like the documentation thing. So you can look at stuff like, well, what does unparse does? It uns the parse, and get like nice documentation comments from the source code. The other bits I have not done as properly. So PureScript Lamness, which is my sort of anti-corruption layer, I think, it exposes functions that you can easily call from JavaScript, and it depends on my Lambda code. But that's just a GitHub project I have lying around. And what I ended up doing was I found this perp command, which is called browserify. It compiles and builds your project, and everything you put in your main.purse file, it exposes as some JavaScript file, which you can require with the require thing. So what I decided was, it turns out that PureScript functions are then exposed like regular JavaScript functions. And if you use types like string and bool, then those are equal to the JavaScript values that are, so you can call them with the regular JavaScript strings, regular JavaScript booleans, and so on. So I made some like helper functions that make it easy to like start with a JavaScript string and get this top level thing, and not have to deal with like what is inside my top level thing in JavaScript code, but instead have like functions that give me strings back. So in order to like make a step of computation, I can from the JavaScript code call parse and then call step, and I'll have the string that is the next bit. So I won't have to like look into the data structures from JavaScript. I mostly deal with sort of simpler types. We could test some of this in the JavaScript console, but I don't think we really have time. But once I have like required it, I do this require thing, and I hold on to lambs. Then from JavaScript, I can write stuff like this, and I'll get stuff back. So if I do lamb step of this stuff, I will get a string back. If I do isJust, I will get a Boolean back, and I can do regular JavaScript code for that. So yeah, this bit of the talk is also kind of showing off how little JavaScript I know. So I later discovered that there are things called like constant things in JavaScript, and you don't have to write function. But in this code, it's done like this. So yeah, I figured like the way to write JavaScript is probably copying and pasting from Stack Overflow, so I've mostly done that. And yeah, then there's the Monaco bit. Monaco exists and is a thing, so I didn't have to build it. And I downloaded a thing that contained like minified JavaScript sources, and I put it somewhere where I could reach it. And then there was this, I don't know if it's a Microsoft thing or just a required thing, but I got bitten by this bit where Monaco uses some other required thing that isn't the same thing as the thing I used for the first thing. And I had no idea what to do. I hacked around with stuff and I put things in different files, and somehow it ended up working. So I think the reason this rec main exists and is not just part of stuff.js, which is a much better name, is that I had to like go around this require nonsense in some way. And the Monaco thing is kind of nice. I do JavaScript stuff. I pick all the elements that I have called lambs. I'm not sure why I'm using a name instead of a class there. But given some HTML page, my JavaScript code will run through it and sort of push in Monaco editor whenever it finds one of these lambs elements. And it will call like start editor with the element as an argument. If we look at so this bit, given an element, we do Monaco editor create. I empty the contents of it first and put it as the contents in the editor. So if you don't have JavaScript running, you will get like the text I wrote. If you have JavaScript running, I will remove it from the HTML, but I will put it in the editor instead. So I can write like an HTML page with sections that are lambda calculus, and if the JavaScript stuff works out, it will pick out those sections and put the contents into little editors. And then there's a couple of examples of doing stuff with Monaco. You do like add command. You can do this. This bit is that I want to be able to press Control L in order to insert a lambda character. So it does this stuff. And again, this is me writing JavaScript. But I wanted to show like one of the commands that like uses my pure script code and uses some of the fancier Monaco bits. So you have stuff like you pick out the line that your cursor is on in Monaco, and there's stuff happening, and here you parse that line with my pure script function, and you do some top-level definition stuff that we want to get into, and later on you insert. Yeah, and then put a new line at the beginning, and then make some Monaco operation where I insert this parsed stuff. Yeah, so that's the Monaco bit, and the remaining bit is, well, doing the HTML page. And I use Racket for writing HTML because Racket is a programming language, and it has parentheses that I like better than this, since it's a variant of Scheme. But it's basically just some web page has regular text in it, and here and there I can put divs. And maybe I should have written name instead of class here. But anyway, sort of throw the appropriate attribute on the divs that I want to be editors, and then I hope for the JavaScript stuff to pick out this stuff and replace it with an editor that contains the same text. And yeah, so the conclusion is like, okay, yes, that worked out nicely. I managed to do the thing I wanted to do, and well, it wasn't as painful as I was anticipating, I guess. We kind of shortened up. I wanted to have like parts and an appendix. So the appendix is the bit that we skip. Yeah, so one time a version of PureScript broke some of my stuff, but it only happened one time, so I'm pretty happy with it. It's on version it's now 0.11 or something. So it probably should be like expected. Elm broke all my stuff, so I'm happy with this. There's type classes stuff. I don't like that if you, so this can be kind of intimidating. So you make like a value of a record type and it just starts shouting at you. This bit we skip. Record punning I thought was weird. You can write this instead of this if the expression and the label you give a thing is the same, which is maybe nice. It doesn't have tuples. It does currying instead. I don't know if you noticed, but I tried to make all the slides that are like this haikus, but at this point I didn't. Didn't want to. Well, I had come up with a lot of 7-syllable things, so this will do. So since it uses currying, so the thing I will say about currying is that it doesn't always do wonders for error messages. And if you, so the typical example is when you forget to pass in the last argument to a function, you don't get like, this is missing an argument because you applied 3 arguments and you got the function back instead of applying 4 arguments and getting something else back. So you might get error messages like this, could not match type, ran to exec with exec, which is nice enough because I can tell that this type is, a value of this type is just missing a ren, whatever that is, in order to give me an exec. But once you get, so the parent function with the fancy types gives you fancier type errors. So if I remove this x, I get this type error. So it has a bunch of type variables mentioned that I did not introduce. And some of them are similar to the ones that are in the type. So like A, B, and M, there's M1 and B2 and A0. So when I get to this, I either stare at the code until I know how to fix it, or I erase all the code and write it again and hope I don't end up here. So yeah, that's it.